Hello, this is Mr. Stansbury. I'm going to take you through the notes on Voronoi diagrams. At the end of this, you should be able to say, I can read and understand a Voronoi diagram, and I know and can identify sites, cells, edges, and vertices for a Voronoi diagram. Okay, so I think the easiest way to take a look at this is to look at an example. So we're going to go through this example here. But before we actually do it, we're going to actually talk about some of the definitions here. But let's take a look. This map shows the locations of 4 fire stations in a city, A, B, C, and D. When a fire starts in the city, it's important for the nearest fire station that the nearest fire station is alerted. Which fire station is closest to all these points, and then they're going to ask us some other questions. So, first things first, we need to kind of know what a Voronoi diagram is, and that's what this is here. Okay, so this here is a Voronoi diagram, and these lines here, basically any house or whatever that's in this yellow region is closest. B is the closest fire station to anything in this region. In the green region, it's all going to be C. Pink is the D fire station, and the blue is the A fire station. Okay. So with that, there's certain little definitions that you're going to want to know. A, B, C, and D are all called sites. Okay. Cells are each of the colored regions. So like all of the pink in here, that's all cell. That's the D cell, or that's like the cell that D services. Okay. We also have edges. Edges are all these lines that separate 2 different cells. Okay, and then we also have vertices, and the vertices are where the edges meet. Okay, so we've got vertices, and then edges, and then cells, and then the sites within those. Okay, so that should hopefully help us to better figure out this stuff here. All right, so on this here, we want to figure out which fire station is closest to 6-3. So they actually... No, I guess we didn't graph that one. So 5, 6, 1, 2, 3. So there's 6-3. Let's come up with a better color than that. That's easier to see. So 6 and 3 is right here. Okay, so which fire station is closest to that? That's gonna be C for sure, right? So that's gonna be C. And then 2, we put in 4, 6. So here's 4, and then we go up to 6. And now it's obviously closer to either A or B, so we have to figure out that distance. So it's pretty easy to figure out the distance to A. That's 1, 2, 3 units away. Okay, from B, we go up to over 1. So really, if you think about this, this is a nice little right triangle, right? And we're trying to figure out what this distance is right here. So really, that's going to be 2. That's 1. So that distance from 4, 6 to B is going to be, let's go do it down here. Let's see, 2 squared plus 1 squared gives us question mark squared, right? So that's 4 plus 1 is question mark squared, and that's 5. That's question mark. So then when we do the square root of 5, so we can take square root of 5 here, and we get 2.23. So this distance right here is 2.23, which is definitely closer than 3. So that means that B is the close. Oops, that's the wrong problem there. Over here is the answer would for 2, or II is B. For C, we're at 3, 7. Let's maybe change our color to make this a little easier to figure out. 1, 2, 3, and 5, 6, 7. So that's that one right there. So if you look here, we're over 2. Down 1 there, so that's 2 and 1, right? So that's A squared plus B squared. We just did that. That's 2.23. Then also, though, if you look here to go to B, we go up 1 over 2. That was a crummy line, but you get the idea. Up 1 over 2. So guess what? That's also 1 squared plus 2 squared is 2.23 squared. I know I'm writing over the top there, but they're both the same, so that's going to be A or B, because they're both, that's hard to read, sorry, A or B, either one, because this here is going to lie right on one of these edges here, right? If the town lies on the edge, look, there's the point right there. It lies right on that edge. That means it's close. It's equidistant from A and from B. Okay, and if it ends up on a vertice, it's actually going to be equidistant to 3. A, like this vertice right here, is going to be A, B, and C are all equally as close. Okay. Oh, spoiler alert. Look at that. So here we are at 4. So let's do that one. Do that in purple. So we're at 4, 4. So that's this vertex right here. Vertices. Vertex is the singular. So there's the vertex of that. So that's the nice thing about once you have this Voronoi diagram, you can actually just use this and plot those points and figure out exactly which one's closest instead of going through and calculating all this out. That's what these lines help us figure out. Okay, so this one here, it's actually closest to A, D, and C. A, D, and C. Okay, so all 3 of those is where that's closest to. That's why these diagram here, I mean, we could have graphed it 4, 4 here, but then we'd have to calculate all these distances, but this Voronoi diagram helps us figure that out. Okay. Part B, station master at fire station D wants to know the region of the city that is closest to his station. What does this region look like? Well, here's D. It pretty much looks like in this case, it looks like a square, right? It's a rectangle, but specifically it appears to be a square because this is 5 units long and that's 5 units long. Okay. How could we improve the map to make it easier to determine the closest fire station to any given location? That's actually what we did here. That's to draw a Voronoi diagram. So we'll do that. Make Voronoi diagram for this thing here. So make that, and that makes it really easy to figure those all out. Okay. And then part D asks how far apart are stations A and B, but maybe before we do that, let's do a quick little comedy break.
Oh, hey, Mike, you kind of cute. You look like Winnie the Pooh. No, I don't. Winnie the Pooh is a fictional bear with no fingers. I have fingers. I hate honey, and I got several different pairs of pants that I wear all the time. That is not a compliment, lady. Stop telling me that. Nobody wants to date Winnie the Pooh.
All right. So, how far apart are stations A and B? So, I've drawn all over this. I apologize. Let's do a new one here. Let's do it in, what color have I not used? Let's try, I did use purple down there below, but let's do purple here. So we got purple. So this distance here is 2. This distance is 1, 2, 3, 4. So that is going to be 2 squared plus 4 squared is going to equal, let's call this x, our distance there, x squared. So 4 plus 16 is x squared, so 20 is x squared. So we take the square root of both of those to figure out what our distance is, and we do square root 20, and we get 4.47, 4.47, whatever the units are in this here. Does it say? It doesn't say. Yep, does not say. So 4.47 units, whatever they're doing, miles, kilometers, feet, I don't know. I'm pretty sure it's not feet, but anyway. Okay, that is all we have for Voronoi diagrams. If you have any further questions, please feel free to ask. Thanks.